Okay, Team Impact, it is January 2nd. We're getting started on our new packet. It is the Expressions packet, Unit 7. You can find this in the Schoology. You can find it in today's homework, Tuesday the 2nd. We're going to go ahead and get started. Hope you had a great year. But it's time to get back to work, people. Let's flip it over, and here we go. Okay. So when we talk about an expression packet, we really talk about the beginning of the algebra piece, the pre-algebra piece. All right, we're going to talk about these things, and we're going to work through these. So let's rock and roll here. So how can we represent the area of these models? All right, to figure out area of a square, a rectangle, a rhombus, a parallelogram, we take base times height, or length times width, right? So what we're going to do is we're going to take the length, which is 4. So it's going to be 4 times 1, 2, 3, 4, and we get 16. You're getting the idea. Instead of counting all of them, we're just going to go 3 times 3, and we're going to get 9. And then finally, we're going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. These were all squares. All right, and we get 25. Now, when we talk about area, it's always going to be in square units. So we would label this unit square, and unit square. We don't know what the units are. Later we will. Inches, feet, miles, centimeters, and so on. Okay? All right, so let's talk about some exponents today. The base is the number being multiplied. By itself. An example, 9 square, or 9 to the second power. 9 is the base. 6 to the fourth power. 6 is the base. The exponent determines the number of times the base is multiplied by itself. Okay? So, the base here is 3, the exponent is 5. So 5 is the exponent. That means 3 times 3 times 3 times 3 times 3. All right, 2 to the 7th power. 7 is the exponent. You're getting the idea of this. So we're just multiplying the base by itself according to the exponent. Any number raised to the second power is said to be squared. Okay, squared. All right. So if we go back to this sample here, this could be read as 9 to the second power, or 9 squared. Any number raised to the third power can be cubed. All right, and we can just put that in parentheses. Okay. All right, let's get started here. All right, quickly, pretty easy lesson. Good one to start with the way back. Our base is 3, our exponent's 4. Our base is 7, our exponent's 3. This is read 7 to the third power, or 7 cubed. 9 square, 9 and 2, right? 8 to the ninth power, 8 is our base, 9 is our exponent, right? And then finally, 12 to the 0 power, 12 is our base, and 0 is our exponent. Okay, so we're going to be working forward and backwards down here. Shouldn't be too bad, but let's go ahead and write it. Base is 5, the exponent's 3, so we write this 5 cubed, or 5 to the third power. 19 square, 19, 2 is our exponent. So this is 19 to the second power, or square, and this would be written as 11 to the fourth power, right? Because 11's our base, 4 is our exponent. Let's continue on. Our base here is 16, our exponent is 4. If we work backwards, our base is 7 and our exponent is 6. And remember, we want to write that 6 a little bit smaller there. Our base is 4 and our exponent is 11. And when we get bigger exponents, we want to use our calculator because the numbers will grow exponentially, if you get my gist there. All right, let's continue on. Now, what does all this mean? Well, we're going to write these in expanded form. So 6 cubed, or 6 to the third power, in expanded form is 6 times 6 times 6. Right? Oops, sorry. 3 to the 6th power means writing 3 6 times and multiplying it by itself 6 times, right? When a number is raised to a power, or when the number is simplified, it is called to be standard form, right? So that's the answer, standard form, right? Okay, so let's work forward and backwards, and I'll grab my calculator just to make sure that we're in good shape here. And let's roll. Expanded form is 5 times 5 times 5, so that's 5 cubed. 5 times 5 is 25. 25 times 5 is 125. You should probably know most of your squares and cubes, right? Standard form is 36. So what times what gives me 36? Well, I know 6 times 6, and I would write that as 6 square. I have to know my facts. 7 to the 3rd power, written in expanded form, is 7 times 7 times 7, and this is getting a little bit bigger. So let's turn our calculator on and clear it. So if I hit 7 and I want to take it to the 3rd power, I hit this little button next to 7. That means to the. And you'll notice it puts the cursor in exponential form. We hit 3, and you have to go to the right to get out of that, and we end up with 343. Okay? You'll be doing that a lot. Okay? Okay, 9 to the 1st power is just 9, which is just 9. 4 to the 3rd power. 9 to the 1st power. 4 to the 3rd power is 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Right? If I know them, I write them. If I don't, I just use my calculator. Not a biggie. I'm going to go ahead and write all these in exponential form and then figure it out from here. All right? So we're going to write this as 3 to the 4th power. This is interesting here, right? We can write this a little bit differently here. So I have two 2's, so it's going to be 2 square times 5 square. So 2 times 2 is 4. 5 times 5 is 25. 25 times 4 is 100. Right? Interesting. And let me go back. This one's growing pretty quick, and I forgot to do that one. But let's take 3 to the 4th power. Get out of that function and hit enter, and we end up with 81. Last one is going to be 3 square times 6 square, right? 3 times 3 is 9. 6 times 6 is 36. I'm going to grab my calculator and take 36 times 9, and I'm going to end up with 324. So it's set up very nicely for us. All right, let's take a peek at this last one here. Right? Okay. 6 students were asked to write an expression that equals 576. Determine which students completed the task correctly and find the mistakes made by the others. Okay. Well, clearly I know that's a good one, right? I know that's a good one. Look at this. These are all addition, so I know Penny is wrong. When we multiply exponentially, it has to be a multiplication sign. Here's another example. This is 9, and 4 to the 3rd power is 64, right? So let's check that, and let's check that. 64 times 9, and we get 576. Is that what we're looking for? It is, but the problem is that's addition. That needed to be multiplication, so Fern is wrong. Okay, let's continue on. 3 to the 3rd power times 4 square. Well, 3 to the 3rd power, 9 times 9 is 81. 3 times 3 is 9. 9 times 3 is 27 times 16. Let's check that. 27 times 16 is 432. No, he's wrong. 3 square is 9. 4 cubed is 64. Let's check that. I think we know this is already correct because, yes, 576, because I checked it over here. So that's a good one. And let's check Grace. Grace exponentially would be 3 squared times 4 to the third power, which is the same as Patel, so we know that that is correct as well. Okay? So, using your calculator, not using your calculator. Let's take a peek at the next page in your homework. It is right here. Get this done for Friday, and have a great day, guys. I'll see you.